So hello again. This is the third problem that I will solve as for the revision problems for the final exam. So here, as you can see, we have a truss and we need to find the force in members FE, EB, and BC. Usually when the question is like this, so it's easier to just take a section. This section should pass through the three members FE, EB, and BC. So here I have FE, this is EB, and this is BC. So let's take the section here. So we need also to state if our members are in tension or in compression. So even in the final exam, if it's not mentioned in the question, you need to mention it. So you need to know, I need to know if the member is in tension or in compression. So don't put just the numerical values. I need also to see if the member is in tension or in compression. Okay, so here we have a pin. So we have two reactions, and at point D we have a roller, so I have just one reaction. So if I take the right part of my section or of my truss, I just need to find dy. To find dy, I need to do summation of moment about A is equal to 0. This is my positive sign convention. So here I have dy multiplied by 5.5, which is the distance to point A, minus 22 multiplied by 3.5 minus 11 multiplied by 2 is equal to 0. So dy is equal to 18 kilonewton. So in this case, if I choose to take the right part, I do not need to calculate the reactions AX and AY. If you choose to take the left part, then you need to calculate these two reactions. Next step is to draw the free body diagram of the section that you selected. In this case, it's the right section. So here I have these members. I have here dy is equal to 18 kilonewton. I have here 22 kilonewton downward force. This is point E, point D, and this is point C. Then here I have FCB, FEF, and here I have FEB. Okay, so now let's start. Let's start by taking summation of moment about T. Why I start by summation of moment about T is equal to 0? Because I have two forces passing through point E, so I can get rid of them and then find my third unknown, which is FCB. So if I take summation of moment about T is equal to 0, I have 18, which is clockwise, which is counterclockwise, so I have minus 18 times 2, and I have here plus FCB times 2 is equal to 0. So then I will get here FCB is equal to 18 kilonewton, and it's in tension because the value is positive and it is similar to what I have assumed at the beginning. So it's a tension force. So here I think I have a typo. Let me correct this. So here I have plus 18 and minus FCB. Okay, so 18 is turning counterclockwise about point E, so which is positive, and FCB is turning clockwise about point E, which is negative. But the answer is correct, 18 kilonewton, which is in tension. Okay, now we found FCB. I still have two unknowns. Let's take summation of moment about B. So point B is actually here. And point B is the intersection of these two forces, FEB and FCB. So if I take summation of moment about B, I can get rid of them, of these two forces, and then I find the third unknown force, which is FE. Okay, so summation of moment about B is equal to 0. This is my positive sign convention. So I have here plus 18 multiplied by 3.5 minus 22 multiplied by 1.5 plus FEF multiplied by 2 is equal to 0. So I will get FEF is equal to negative 15 kilonewton. So I can say that it is equal to 15 kilonewton and it is in compression. Okay, because it's opposite what I have assumed here as a tension. It's negative, so it should be the opposite, so it's in compression. Now to find the third unknown force, which is FEB, I can just do summation of forces about y is equal to 0. This is my positive sign convention. And now I need this small triangle to be able to project on x and on y. So I need this triangle here. So let's check what do I have here for the vertical. So this is my EB. So I'm looking into this triangle here. So for the vertical, I have 2, and for the horizontal, I have 1.5. So here I have 1.5, and here I have 2. Then the third side will be 2.5 if you just use a Pythagorean theorem to calculate the third side. So now I can easily find FEB. So here I can say minus FEB multiplied by the vertical, which is 2, over 2.5, the hypotenuse, minus 22, which is downward, and plus 18 is equal to 0. So we can find that FEB is equal to minus 5 kilonewton. So it is equal to 5 kilonewton in compression. Just one remark for the truss problems. Don't forget to review very well zero force members. There are two scenarios or two cases for the zero force member. It's already explained very well in the course lectures and the explanation. So make sure that you know it, because for sure the first question in the truss problem will be identify zero force member and then find the force in 2 or 3 members, and then you need to specify if it's tension or compression. Okay, for the zero force member, you have two cases, as I said. Either you have the case of 2 members together or the case of 3 members. So just review very well these two cases when I have a zero force member, because for sure you will get it as a question, the first question in the truss problem.